All right, greetings. So the previous session in part one and 19 part one, we did division. We covered some division examples without using the division operator, both iteratively and recursively. So we'll do multiplication, and then we'll see how much time we have left over. If we can start working on the Eclipse setup, and then maybe looking at some old projects. Okie dokie. So this is where we left off. Let's pull this up. Okie dokie. So in our main, we called our div r is recursive, del l is the loop, or iterative, as some people might call it. So as we recall, essentially, if it was taken away, if the division operator was taken away from us, we would most of the time just write this while loop, and that would pretty much accomplish that task. But if, for example, you were asked to do it recursively, we wrote this. So it's really important. Error checking, and then making a base case. So there's two things that you should always look for when you're trying to identify whether or not you're using recursion or not. The first is that there's a base case, and the second is that you see the method or member function calling itself. Those are two good indications that you're dealing with recursion. If something is calling itself one or more times within itself, that's recursion. And you also need to have a base case, because otherwise the program will never finish. Or it'll finish in the sense that it will kill a computer, or it will be killed by the operating system. So yeah, so we have error checking, we have a base case. This is essentially where the number is, where whatever's left over, the remainder, at this point, so arg0 is the remainder, and then arg1 is the divisor in the context of this base case. And what happens is that each time we recurse, we subtract the numerator by the denominator, and that's what we pass on to the next one. Yeah, so it's like when I ask you the question of how many times does something go into something else, all you do is you just keep subtracting until you get to this point where the number that is left over, the remainder, is smaller than the thing that you're dividing it by. And in that base case, you could say 0. If you knew that whatever you were dividing by was always a multiple of the divisor, you could have code that looks like this. This would allow us to save one method call. The issue, though, is that it takes up a lot of memory having this extra line of code here. So that's why we have it commented out. So if we had some knowledge about the kind of data that we were calling this on, we may put this code, we may put this line in, or we may leave it out. Okie dokie. So that was iterative and recursive division that we covered in the last session. So now let's do the other two. All right. Okay. So let's just copy pasta these guys. And we'll just rename them. Okay. So this is going to be multi. Okie dokie. And right now we're just going to leave we're just going to leave this code, and we don't need that because that error doesn't happen anymore. Okay. Okay. So then we're going to do this one. I'm sure I'm making spelling mistakes. Okay. So in the case of the iterative or the loop, the for loop actually makes a lot of sense in this context, because we know exactly how many times the loop's going to run. So we're going to say for int I equals 0 as long as I is smaller than, and so we can decide which one we want to go which way, but we're just going to say we're going to add arg0 arg1 number of times, and you could flip it. Multiplication works either way. So, and then we're going to say I plus, and then all we're doing is we're taking result plus equals arg0. So there we go. So, and if we wanted to flip it, we could just say this is args1 and this is arg0 if we wanted to add args1 together arg0 number of times. So let's think about it. If we multiply, if args1 is 0, then this here is going to be false and it's 0. If this is 0, then, but this is, let's say 10, we're going to run through this for loop 10 times, adding 0 each time. If we were concerned that that might happen a lot, we might have something to check to skip all of that. But in this case, this code will work, but when you multiply by 0, it'll take a while. If it's the case that this is the 0 and not this. If args1 is 0, then it's going to be very quick. It's going to immediately, that for loop is never going to run, and it's going to return 0. But if the arg0 happens to be 0, it's going to run through that for loop quite a few times. Well, it's going to run through the args1 number of times, adding zeros. Okie dokie. So that's the iterative or the loop way of doing multiplication. Now let's do the recursive way. So in this case, we're going to do something very, very similar, in the sense that we're going to use one of these as a count of how many times we're going to multiply. So let's do the same thing here. We're going to say args1 is going to be the count of the number of times that we're going to multiply something by. So here, we're going to essentially decrement args1 each time. And when args1 is going to be, and keep in mind, we're dealing with integers. It makes it rather convenient. So when this is, so actually right now it's only going to be able to handle unsigned in this case, because like, for example, this for loop can't deal with, if this is negative, then it's never going to run. So right now, these are all dealing with positive integers. And we might reflect that by changing this type to be an unsigned integer. Okay, but for now, let's just say, we're just going to say and actually just in case somebody calls it, if args1 is smaller than or equal to 0, in this case, for us, it's really only going to be 0. But if somebody gives us a negative number, we're just going to return 0. So our code is going to essentially give a wrong answer instead of continuing to run forever, or until you run out of stack or heap space, depending on what's if you run out of memory, or if you recurse too many times first. Okie dokie. All right, so there's our base case, and then now let's do our recurse. So here we're dealing with in terms of arg0. So it's going to be arg0 plus. So if it happens to be, so if you multiply by 0 here, then we return 0 immediately. If this was a 0, then we're going to just be adding lots of zeros together. Okay, so now we're going to say that. Let's see. So if it's 1, let's run through this in our heads. If this is 1 and 1, let's just say 1 and 1, 1 times 1. We're going to take, so 1 is not smaller than or equal to 0, so this doesn't run. Then we return 1 plus, then this. This is 1, comma, 0, which then recurses and calls this. This is 0, so we return 0. So this whole piece here is 0. So it's 1 plus 0 is 1, and that's what we ultimately return. Okay, that sounds good. Let's now run it for 2 in our heads. So let's say 2 times 2. 2 times 2. So we say, is 2 smaller than or equal to 0? It is not, so this doesn't run. Then we say 2 plus multi-r. This is a 2. This is a 1. And we recurse. So the 1 is not smaller, so then that doesn't run. Then we take this, which is 2, and then we recurse again. This is 2, and this is 0. Then we're recursing. We go, we run. It's 0, so we return 0. So then that second one, this piece is 0, and then we recurse again. This piece here that was left over is going to be 2. So it's 2 plus 2, and that's what we ultimately return in the end. Cool. Okay, so let's make sure that what we ran in our heads is actually what's going on. So we're going to stick these here. So this should be 10. Oops, sorry about that. going to be 10. And let's flip it to make sure that that works. And let's call both of them to test them out. Right. Okay. And there we go. That looks good. And of course, we would probably want to do more testing. We want to test to make sure that our base cases are working properly and whatnot. Okay. All right. So that was pretty quick. Hopefully everyone's okay with that. If you have any questions, let me know. All right. And so I'll re-upload this to GitHub with the added two methods. Okay. All right. So let's set up Eclipse. So one of the things that you have to do before you set up Eclipse is you have to install the Java JDK. And so if you're running Windows, for example, then you need to, if you just go to Java JDK, you can pretty quickly download an older version, or here's a more recent version. And so you would download it, you download this guy, and then you would go through the install process. Oh, nice, they have a Debian package. I should have used that. So otherwise, you can use any of these installers. Yeah, so if you're running Windows, then you probably want to go with this guy, install it, go through the process. Your path might get messed up, or your path might not exist properly. So if you open up a terminal and type in Java or Javac, it might not work. So just know that that's your path. You have to add where you installed Java to your path. Unfortunately, I'm not running Windows right now, so I can't show you how to do that. But if people are having problems with that, let me know, and I'll be happy to boot up a Windows system and show you how to add things to the path. And you could experience a similar problem in Linux. There are, to add things to your path, you can add it to your, there's a few different files that you could add it to, but let's see if we say, if we add it to, let's see. Sorry, I have some robotic stuff working around. So you could add it in here. You could also, let's take a look at our .profile. Here we go. So we would add it and it would look very much like this. And we would figure out where the Java install was, and we would add it essentially to where we say path equals, and then wherever the Java is. So in my context, I would know that it's already living in bin, which is already on my path, so I'm good. But if I say, but it actually happens to be living here, which isn't on my path, so I would stick that right here. And that's what that's doing, is that's pre-appending. What my path used to be is this, and so now I'm adding this in front of my old path. So everything that was on my path is still on my path. That's really important, because otherwise you'll lose the ability to do a lot of things. Okie dokie. Yeah, in Windows, it's a bit cleaner in Windows on how you do that. And that was the my .profile file in Linux. Okie dokie. So yeah, so you download this guy first, you install it, you open up a terminal, make sure that you can say Java. You can say you can do that, and that you can do that. So yeah, make sure that you can run Java and that you can run Javac, and that's a good indication that your path is good and that those are both installed. And then from that point, you can install Eclipse. You can install Eclipse. And there's of course a few ways to do it. In this case, you could just download it and run the. If you download it, if you're running Windows, then it's just an exe file, and you just run the install and you just step through it. If you want all of your projects to be in a specific spot, make sure to set that up. When it asks you where you want to place your workspace, that's what it's asking, is where do you want all of your files and projects to live. So yeah, make sure to not give that a whimsical name, because you might be stuck with it for years. All right. So once you go through that process, then you can run Eclipse. And so there should be a shortcut on your desktop. Sorry, you can't see this. I have to wait for it to finish loading. There should be an icon on your desktop. And okay, yeah, so here we go. So right here, it's asking me where I want to place my Eclipse workspace, because I have never, I've not started Eclipse yet. I just finished installing it. So in my context, I'm actually going to stick it in Dropbox and in Dropbox CIS classes. CIS CS classes. That's sort of just my general dump zone for all of my various projects. Okay, and then launch. And then it's going to say this workspace was written by. So because I've used Eclipse before in this particular spot, I am going to just say continue. So it's a Dropbox folder. So I have lots of systems that are all watching that folder for all of my projects. So I have other computers, for example. Okay, and let's see, there's a complaint about now. Yeah, so some of my old projects are in a strange state. And there we go, we have Eclipse. So now let's make a new project. Oh, let's make a new project. And we'll call it greetings. And so here you would select your Java version. Make sure to use the most recent that you have, that is a real Java and not some ICE-T or OpenJDK or anything like that, because you might encounter some problems. You shouldn't in this class, but you might. So it's best to use the Oracle stuff. And then let's see. Create a subfolder for sources. So yeah, so in this context, if you were working on a big project with lots and lots of files and images and other kinds of things, you would want to do this create separate folders or for sources and class files. This will also, when you have your .java files, they'll live in one spot, and then your class files, your compiled code, will live in another spot. This helps declutter. But in this context, we're just going to dump everything in that folder here. So that's what this option is here, is just whether or not we separate everything into separate folders or directories, or if we just dump everything into the root folder. Okay, next. Yeah, see, this is one of my old one of my old projects is being grumpy. Okay, so this is just a review to divide. So if you had extra libraries, say something that was some kind of third-party, fancy thing that does something really cool, some graphics library that that has laser beam animations that looks really nifty, or something that you want to include, or some code that's external to Java or external to you, or actually it might even be your old code that's all packaged up. You would add it here in the libraries, and this, if you have those extra packages, you may change the order, and then dependencies. So in this context, we shouldn't have to care about any of that. We should be good. So we're going to say finish. Pretty much in this class, we don't have anything super exotic happening. Okay, and then it should be hidden in this view. So we might change our perspective just to make our lives a little bit easier. Let's see, perspective, open perspective. Yeah. They've moved things a little bit. So I'm just going to minimize that. Open up greetings. There's all that stuff. Oh, so actually I don't need that view. Sorry. There should be just a Java perspective. So let's just say reset perspective. Yes. So we want the toolbar. I'm not sure why I'm getting all these bases here. Whatever. Okay, so as you can see, things are pretty customizable. We don't have any types that we're working with. We don't care about any members yet. So let's just make a file, and then within this project, so we're going to say new class, and we're just going to call it main, and it's going to say that it's not a good, but we're just going to, we'll just call it example, and it's going to be a public class. We don't deal with any kind of packages. We'll ask it to just dump a main in there, and then we'll generate some comments. Okie dokie. There we go. And so this is highly customizable, this view. So if you wanted, most of the time people have this on a sidebar like this. In the default view, I don't know why we see all of these guys, but whatever. I'm just gonna collapse that for now. Okay. And then typically we would stick like a debug console or something down there. I don't know why, but I should have the all of those in the perspectives, in the default perspective. So there's a console, there's the error log. There we go. We're going to minimize it. All right, greetings. All right, greetings. So we just did some recursion with the division and multiplication operators, and then I'm stepping through setting up Eclipse. All right. Yeah. So that's where we're at. Did you have any questions, Suji?
No, not at the moment. Thank you.
Okay.
This is actually perfect because I'm not very familiar with Eclipse either.
Oh, okay. Yeah. So essentially, what happened was that we you install Java. So you just say JDK install, and you go to the Oracle website. Oops. And then you download one of their JDKs. And if you're running Windows, then it's just going to be an exe. If you're running a Mac, then it's going to be one of these. So you install these first, and then you open up a terminal. Make sure that you can say, Java, Java -- version. Make sure that whatever's showing up here is what you just installed, and then also make sure that you can run Javac, and that's a good indication that your path that you installed successfully and that your path is set. If your path isn't set, if you get like a command not found, like Javac, whatever, if you get something like this, a command not found, then something's going on. Sorry about all these errors. I decided to import my previous workspace, and that's of course messing up my Eclipse instance. Yeah, so let's go through making a new project. So we're going to say file new, and then Java project. We're going to call it G2. The Java execution environment, that's the thing that you just installed. So that's the JDK, the JRE, which is included in the JDK. So that's the Java runtime environment, is going to be in the development kit, which is Java development kit, JDK. So yeah, make sure that the thing that you just installed is here. And then here, this option, in this class, we're pretty much going to stick with this one here. Use project folder as root for sources and class files. That essentially says that all of the stuff that we're working on is going to be in one directory. If we wanted to split things up, like for example, have our .java files and our .class files to be in separate folders, then we would use this option. When projects get more and more complex, especially when you have lots and lots of classes, it can become very, very messy. So having them split up is nice using this option. But in this case, for this class, this is perfectly fine for us. All right. And sorry,
I have a quick question.
Yeah.
The bar that says Java SE-13, what are the other options? Like, what's the difference? I don't know if you already went over that.
Oh, okay. Yeah, so there's lots and lots of versions and flavors of Java. Not only does Oracle release a lot, so all of these here are all Java versions that are released by Oracle. But then there's open versions. There's ICE-T, and there's also OpenJDK that are free, uppercase free and lowercase free to use. The issue with those is that they're not exactly identical. So the more advanced projects you get, you might have weird things that break if you're using the other versions of Java. And so like me and Jeff, we actually had a discussion about this, because it's like when you're using Oracle's version of Java, if you're using it professionally in a product that you're making, the companies have to pay licensing. They actually have to pay Oracle money to be able to use them. And in the context of this class, we're not making money and we're not making a product that is our code. So that's not a concern. So we don't have to pay Oracle any kind of licensing. So there's the trade-off of, like, if you were using ICE-T or OpenJDK, those are free to use and they're free for you to write code and then release. Did that answer the question?
Yeah, thank you.
Okay, cool. Yeah, so that's what's up here is, and in the scope of this class, we run the bleeding edge because it's because it has the most coolest features and whatnot. Sorry, this is my periodic workspace save. So this is my my method count code that I wrote years ago is being grumpy. So yeah, so here we really don't need to be concerned with any of this stuff, but just so we know. If we wanted to include it in a project, or we were using external libraries like some kind of cool laser animation that somebody else had wrote, or maybe code that you had written previously that was in a package, you would add it in this library. And sometimes the order in which you bring them in and that you use them matters, so you can specify that here. And then also, if you have particular modules that are very picky about which libraries they're using, it's called a dependency. If they need a particular version of something, that you would set that all up here. But nothing in this class will have to deal with any of these guys here. But just something for us to know about. Okie dokie. And then we can hit finish. And then here we go. We've got our and I don't know why all of this is showing up. Most of the time with Eclipse, all of these extra packages don't show up, but we can ignore them for now. It's probably because of my workspace is a bit messed up because I tried to open an old workspace. So then the next thing that we're going to do is we're going to go G2, new, and then we're going to create a class. And so we're going to call the class name the same thing as the source name. It says it's strongly discouraged. And then if we had some kind of inheritance structure, we would modify this superclass in the interfaces. And Jeff's going to be talking about that. Well, he talked about that a bit, and he'll keep talking about it. But yeah, if we had a project that was using other code, inheriting it in some way, we would be using this. We're going to make it public. We're going to create a main, and there we go. And now we have our main that's automatically generated. And so then we could code, and then if we system.out println greetings. Now we can use these little guys up here to run our code. If we just wanted to run it and we want to see it in the console, so yeah, we're going to save it. And there we are. There's our greetings. But if, for example, we wanted to step through it, we can click this little debug, and that will take us in, and then there's a different perspective. Oh, is not supported. So I'm running the bleeding edge, which apparently advanced source lookup is disabled. Yeah, and I don't have the source code installed, so I can't do the debug apparently. Oops. So there are different versions of Java, and so you can play around and you can change that in the settings to make that work. But for the most part, you don't really need to step through code unless something's really, really broken. And Jeff has done that in class in some of his recordings. So let's see. Oh, can I change the debug configurations? JRE. Let's try. Yeah, I don't know. Nope, that one also doesn't support it. Yeah, so essentially what you would do is you go into the debug configurations and you would go through and you would try, if you get this error, you would try different execution environments. And I only have one JRE installed, so that's probably what's messing me up. And I'm running a bleeding edge version. So yeah, so I think that's what's going to hang me up in this context. But yeah, you can install other versions of Java, and older versions will work. In this class, we really don't do. I mean, you could probably be running Java 8, right? We're at Java 14 right now. But you could probably be running Java 8, and you're not going to see any real differences until we start talking about GUIs, like in the last week of class, if we even cover that at all. Okay. That's Eclipse. And then if you wanted to add more classes, right, you just keep right-clicking, say add new class, and you just keep adding those. And that's just the same as if you were in Nano creating more Java files. All right. What's up?
Oh, I was just saying okay.
Oh, okay. So when does class start?
It did start at 5:30.
Oh, okay, cool. Okay, so I've got 9 minutes. So yeah, I was gonna go and look at some really old Java code. Was there something that you wanted that in the last few minutes to go over?
No, nothing specific. Just wanted to come in here just to see and like refresh what was said in lecture.
Oh, okay. Yeah, so I could pull up some of the recursive stuff that we were playing around with earlier in the session. So, I was doing, so initially we started out with doing, let's look at the iterative part first, and let's do multiplication first, just to make our lives a little bit easier. So if for example, we took away the multiplication operator, the way that we can get around that, if I said, you no longer have a multiplication operator, how do you still multiply? You could do that with a for loop, right? You can add, if you add args0 together, args1 number of times, then that's going to be the same as if we multiplied it. And the reverse is also true. If we flip these two, it would be exactly the same operation. And we're dealing with, in this context, we're dealing with unsigned integers, so we're not having to bother with negative numbers, because right now, right, if args1 was negative, then this code wouldn't work properly. So we're sort of omitting some data to make our lives easier. What we could do is we could convert, if we detected that one of these was negative, then we could save the sign and then do the operation as if it was positive, and then put the sign back onto it. But right now in this example, we didn't care enough. So if we then made it recursive, so if we did the same thing, so this is iterative or via a loop. But if we said, oh, you have to do multiplication without the multiplication operator recursively, then you would probably need to do something more like this. And the thing to take away that's really important whenever we talk about recursion is that you need a base case and that you need to call yourself. So here's our base case. We are going to stop the multiplication when we hit 0. Or sorry, when args1 hits 0. So essentially args1 is a thing that's keeping track of how many times we're going to multiply by. So the same thing here in this for loop in the iterative is that this args1 is keeping track of how many times we're going to multiply by.
Okay.
So here in the recursive, this tells us when we're done. When this is 0, that means that we're done multiplying. And we could even change this to the number 1. But right now, this makes it so that if this is 0 or this is 0, that our code still works. And if somebody gives us a negative, then instead of us just recursing forever, we end up just giving a bad result. So if somebody gives us the number 0, then we're just going to give, we're just like, if somebody put in 5, and then 0, we're going to return 0. That's going to be fine. But if you flipped them, then it's gonna do, it's gonna be a mess. So anything that's negative is not going to work. Okay, so yeah, base case. So we're going to stop at 0 essentially, and we're going to give 0. So if args1 is 0, then we return 0 or negative. If this is negative, then we're also going to return 0. So that's something important to know, that in the bounds of what's written right now, we're going to return an invalid number. All right. And then the next thing to look for when you're recursing is that you're calling yourself.
Right. Okay.
So this is the number that we're going to be adding to. We multiply, we call ourselves, we pass in the same thing, and then we decrement the number of times that we're going to recurse. And so essentially each time we recurse, this piece here is going to get, this args1 is going to get smaller and smaller and smaller until it hits 0, and then we're done.
Okay.
Yeah, so very much similar to how the for loop's running, that this args1 is used to keep track of how many times we're going, but instead of us messing, and we could just decrement args1 each time in this loop. So instead of using I anywhere here, we could just say, if we wanted to make it even more similar, we could just say, you know, for that, and then we could say args1 is greater than or equal to 1, and then we can say args1 minus minus, and then we just do exactly the same thing here. So yeah.
I was wondering, when is a good time to use a recursive, or use recursion?
So recursion is really good for dividing and conquering. Most of the time when you see recursion where it's just calling itself once, that's a pretty good indication that you could solve the problem with a loop like this. But if you see something where you're breaking a problem into smaller and smaller pieces, then recursion makes a lot of sense. I don't know if I can pull up. So a lot of sorting algorithms, for example, like when you call ArrayList.sort, that's using a recursive in the background. That's actually using a recursive method in the background. But let's see. I don't know. Do I have any of the? This is recursive.
Oh, yes.
I don't know if you've seen this in Jeff's classes before.
Yeah, I think I saw it in CS-19.
Okay. Yeah, so this is a form of Pascal's triangle, and this makes a lot of sense because if I have a ton of threads or processors on my computer, I can essentially give each of these tasks to a separate one. So otherwise, if I wasn't using recursion, if I was just using like a for loop or something to come up with this, and Jeff did an example in class of sort of the efficiency that you see when you do stuff like this, being able to divide up, imagine that each of these blocks down here was a separate computer or a separate processor that was responsible for coming up with that answer. You can implement distributed computing. Stanford does this a lot, where some person comes up with an algorithm that says, yeah, I think that this algorithm here will come up with a protein sequence that will cure this form of cancer, and then they take that algorithm and they say, here, this computer, you run this piece, this computer run this piece, and this computer run this piece. And then everybody comes back and collects all of their answers. And then maybe there's a next stage where there's a server collects all those answers, and then gives, like for this computer, gives these two answers that were produced by other computers to this guy, and this guy then comes up with that answer. So for distributed computing or dividing processes up, which is really important in today's world because we have computers all over the place, and being able to break up a task, even if you're running on one computer, your computer has lots of processors in it. It has lots of different kinds of processors that are all specialized for different things. So being able to think in a way that allows you to break up a task is really important. And I think we're going to hop over to Jeff.
Okay. Thanks, Carter.
Yeah, no problem.
Bye-bye.